Welcome back to PharmaWire. Today, we are diving into the fascinating world of pharmacodynamics. This is where we explore how drugs interact with our bodies. Pharmacodynamics. It is the study of how drugs interact with the body to produce their effects. Most drugs work by binding to specific receptors, which are macromolecular components of cells. Agonists are drugs that bind to receptors and activate them, producing effects similar to those of the natural substances that bind to the same receptors. Antagonists are drugs that bind to receptors but do not activate them. Instead, they block the effects of agonists. There are two types of antagonists: competitive, bind to the same receptor site as the agonist, and non-competitive, bind to a different site on the receptor or a related molecule. Agonist-antagonists have both agonist and antagonist properties, activating one type of receptor while blocking another. Some drugs work by interacting with small molecules or ions in the body, rather than by binding to receptors. Receptors are specific drug binding sites that mediate the action of drugs. While some drugs interact directly with receptors, others target ion channels, enzymes, transport proteins, messengers, or genes. Drug-receptor interactions can involve covalent, ionic, or van der Waals bonds. Ion receptors are found in excitable tissues like the CNS, neuromuscular junction, and autonomic ganglia. Agonists that activate ion channel receptors can cause depolarization or hyperpolarization. Receptors can become desensitized or downregulated with repeated exposure to agonists, leading to decreased effectiveness. Conversely, chronic antagonist administration can lead to supersensitivity due to increased receptor synthesis, upregulation. Prospects of drug action refer to the various ways in which drugs can interact with the body to produce their effects. These include 1. Pre-resorptive action, drugs that act before being absorbed into the bloodstream. 2. Resorptive action, drugs that act after being absorbed into the bloodstream. 3. Reflexive action, drugs that produce effects through indirect physiological responses. 4. Main action, the primary intended effect of a drug. 5. A direct action, drugs that interact directly with their target receptors or molecules. 6. Indirect action, drugs that produce effects through secondary physiological changes. 7. Adverse action, unintended or harmful effects of a drug. 8. Specific action, drugs that have a highly targeted effect on a specific biological process. 9. Non-specific action, drugs that have a broader range of effects. 10. Reversible and non-reversible action, drugs that can or cannot be reversed in their effects. Principles and types of drug action. Principles of drug action refer to the underlying mechanisms by which drugs exert their effects. These can be categorized as physical, drugs that work through physical means, such as adsorption or absorption. Physical and chemical, drugs that combine physical and chemical properties to produce their effects. Chemical, drugs that work through chemical reactions. Biochemical, drugs that interact with biological molecules, such as enzymes or receptors. Concurrent, drugs that work together to produce a combined effect. Types of drug action can be classified based on their effects on the central nervous system, CNS. Sedative, drugs that reduce anxiety and promote calmness. Depressing, drugs that decrease activity or function. Paralyzing, drugs that cause muscle relaxation or paralysis. Tonic, drugs that increase muscle tension or tone. Stimulative, drugs that increase activity or function. Pharmacological reactions to drugs can be categorized as normal reactions. Line dependence, effects increase linearly with dose. Parabola or hyperbola dependence, effects increase rapidly at low doses and then plateau. Similar dependence, effects increase rapidly at low doses, then plateau, and finally increase again at high doses. Decreased reactions. Tachyphylaxis, decreased response to repeated drug administration. Tolerance, decreased response to prolonged drug administration. Drug dependence, psychological or physical dependence on a drug. Increased reactions. Idiosyncrasy, an unusual or unexpected response to a drug. Allergy, an immune-mediated response to a drug. Sensitivity, increased response to a drug due to prior exposure. Drug interactions can be antagonism, drugs that counteract each other's effects. Physical antagonism, drugs that physically interfere with each other. Chemical antagonism, drugs that react chemically to form an inactive compound. Functional, pharmacologic antagonism, drugs that compete for the same receptor or act on different pathways. Synergism and drug accumulation. Synergism occurs when the combined effect of two or more drugs is greater than the sum of their individual effects. There are various types of synergism. Summing or additive synergism. The combined effect is simply the sum of the individual effects. Potentiation synergism. The combined effect is significantly greater than the sum of the individual effects. Direct synergism. The drugs act on the same structures. Indirect synergism. The drugs act on different structures. Absolute synergism. The combined effect is the sum of all individual effects. Non-absolute synergism. The combined effect is the sum of only some individual effects. Drug accumulation can occur when drugs are administered repeatedly or over a prolonged period. There are two types of accumulation. Material accumulation. The drug accumulates in the organs and systems. Functional accumulation. The pharmacological effect accumulates. Cardiac glycosides can exhibit both material and functional accumulation. And that's a wrap for today's video on pharmacodynamics. We'll be back next week with part 2, so stay tuned for more in-depth information. Please leave comment below if you have any question or suggestion. Don't forget to subscribe to our channel for more informative content. See you next time.